Okay, in our subsequent class, we made mention of area under an enclosed curve. Now let's go further into solving some questions that will help in enhancing our knowledge on areas under enclosed curve. Let me say, for example, you're being told to find the area enclosed between the curve. Between the curve y equals 17 minus 2x minus x squared and the line y equals 2. Now the first thing we need to do is let's have a nice. Now the first thing we need to do is to solve for the value of x in this region. Let's solve this and get the value of x. Remember, they said y is equals 17 minus 2x minus x squared. Now they said the line is y equals 2, so we are substituting y to be 2. The equation becomes 2 equals 17 minus 2x minus x squared. So therefore, now transfer everything to this other side. We now have it to be x squared, because if minus x comes to this side, it becomes positive x squared. Now this goes to, it becomes plus 2x. Now we have minus 17. Then we have our plus 2 here, plus 2 equals to 0. So we now have x squared plus 2x minus 17 plus 2 is minus 15 equals 0. Now what are the factors of this? Let's solve. This is now a quadratic equation. Quadratic equation. Now if we solve this quadratically, the two factors of x are minus 3 and 2, because two numbers are here at 5 minus 3 and 2. So we have x squared minus 3x plus minus 3 and 5 plus 5x minus 15 equals 0. We now have the value of our x minus 3 plus 5 x minus 3 equals 0. So this is equivalent to x equals 3 or minus 5. Now these are the two areas where this curve is being bounded. So our equation can still be written as, now we are looking for the integral of the upper value is 3, this is minus 5, of 17 minus 2x minus x squared. Now we've gotten the 2 points, the boundary points. Now on solving this, we now have it that we are to integrate this dx. Now if you integrate this, the value becomes 17x minus x squared minus x3 over 3, which are 3 here and minus 5. Remember the rule we are using in integration. Our rule for integration, let me just put it at the top here, is x is by n plus 1 over n plus 1. I'm stating here so that you apply it at this point. Now let's substitute the value of 3 here, and x will now have 17 times 3 minus 3 all square minus 3 raised to the power 3 all over 3 minus, you open the next bracket, 17, this one becomes minus 5 minus 5 square, then you have minus, then minus 5 cube all over 3. Now these are value, and now with this the final value becomes 33 plus, and this other side we have 205 over, is 205 over 3. So 3 is 99 plus 205, which is equal to 304 over 3. and which is equal to 101.33 cm. So the area being enclosed between this curve and this is equal to 101.32 centimeter square. Now we can also apply integration into solid revolution, checking the area of solid shapes and a trapezoidal root. So this is integration application. Now with what you're seeing right in front of you, states a solid which has a central axis of symmetry is a solid revolution. For example, a cone, a cylinder, a vase, etc. So solid of revolution, it talks about a solid which has a central axis of symmetry. Now they said consider the area under a portion AB. Now under this portion, let's say these are A portion, this is our B, of the curve Y. Now this curve is Y equals to fx, revolved about the x-axis through 4 right angles. This 360 degrees we have here, so being 360 degrees. Each point of the curve described is circle centered on the axis. Is a solid revolution can be thought of as created in the way with the circular plane ends cutting x in the x-axis and at xa and xb. So what they're trying to tell us now is the region bounded by this curve is 360 degrees. This other one is 360 degrees, and this one at this point is 360 degrees, and it can be used into solving questions and very simple questions on application of integration. Now let's solve the question that is in front of us. We call this our example 1. Let's say, for example, the portion of the curve y equals x square. So this curve has y is equals to x square between 0, x0 and x equals to 2, 0 and 2 is rotated completely around the x-axis. Find the volume of the solid generated. Now when you're talking about the volume, the 2 points has been given to us, and I said it's bounded integration. So first of all, we would have to write down the 2 points, 2 and 0. Now what are we talking about here? We are talking about generating x square and this. So, and we're talking about a revolution. So the first thing here is pi y square, because it revolves where? In 360 degrees. So it's in pi radian. So it's pi y square dx. These are area of concentration. But we're being told at the same time, remember in integration, pi here is a constant term, so it is permitted to lift the arc and it becomes 20y square. But don't forget that the value of our y is x square, so it becomes pi in bracket 20 x square all square dx, which is equivalent to pi in bracket 20, 2 times 2 is 4, x raised to power 4 dx. Now we can now integrate this very function, x raised to power 4. It becomes pi. If you integrate x raised to power 4, you have x 5 over 5 in bracket 2 here and here 0. So with our rule, this is equivalent, the volume is equal to, we have our pi in bracket 2 raised to power 5 over 5 minus pi 0 over 5 over 5. So everything here becomes, everything in this axis becomes 0. So our final volume will now be equal to pi 2 raised to power 5 is 32 over 5. So the volume of this is 32 over 5 pi. So you can now see that we can use bounded line into solving equations that involve integration. integration. Now, when we talk about the trapezoidal rule, just like we used in our last section, the trapezoidal rule said there are many indefinite integrals which can't be evaluated and thus require advanced techniques. Example, you use this and use this. So we are still talking about the bounded shape. So we can find an approximate value for such integrals by finding the area approximately. So we can find the approximate value by approximately finding the area. There are many methods of doing this. That such methods include the trapezoidal rule, and this is what we want to deal with at this point. Now, this is a trapezoidal rule. What it talks about, these are the various values of x n, x1, 2, 3, 4, to a point where you get xn plus 1. It proceeds. Now, this is called the trapezoidal formula. With this formula, we can apply this into solving any question that have to do with the trapezoidal rule. But for now, I would like to say a very big thank you. This is just a recap of what will be taking place in our next lesson. I would like to say a very big thank you for being part of today's lesson. I'd like you to use the test that will be coming up shortly to refresh your memory on what we've just discussed. Do well to use this lesson notes on the platform for better information on the topic we've discussed. Thanks for being part of this.